In the second part of chapter 2, we are going to be talking about percentiles and upper and lower fences and outliers. So first off, what is a percentile? Now, percentile, given by the notation p sub k of a set of data values, is a data value such that k% of the observations are less than or equal to the value. Okay, now what does that even mean? That's super confusing. So first of all, think of a percentile as a cutoff point. Okay, this is a cutoff point. Now, what does it cut off? Well, it's a cutoff point so that k% of observations are below that. All right, I'll give you guys an example. When my son went to, I think it was his fifth annual checkup, his medical checkup with his doctor, the doctor said that your son is in the 95th percentile for height. Now, a percentile and a percentage are very different. A percent is always out of 100, whereas a percentile is a cutoff point. Okay, now what does it cut off? So imagine that, my son was a 5 at the time, I think. This is the shortest 5-year-old in all of the United States, and this was the tallest 5-year-old in all of the United States. A percentile is a cutoff point. So let's say this is my son's height, whatever his height was, I forget, at 5 years old. Then 95% of other 5-year-olds are going to be below him. And then the other 5% are going to be above him. So 95% of kids are going to be shorter than him, and the other 5% are going to be taller than him. And that's what a percentile is. It's a cutoff point so that 95% of values are below and 5% are above. Then the doctor at the same time was like, your son is in the 33rd percentile for weight. So my son is a short, tall, skinny kid. So once again, what does that mean? It means that for 5-year-olds, and again, he's only been compared to other 5-year-olds. So if this was the lightest 5-year-old in the US, and this was the heaviest 5-year-old in the US, then my son's weight is once again a cutoff point, so that 33% of other 5-year-olds weigh less than him, and then the rest, so 67% weigh more than him. So that's all a percentile is. It's a cutoff point. So a couple of other examples here. If you're in the 80th percentile, then 80% of values are lower than your value. On a 20-question math test, the 70th percentile for correct answers was 16. So let's say that these are all the scores on the math test. This is the worst score, and this is the best score. Somebody who scored a 16 out of 20. So somebody who scored a 16 out of 20 is going to be somewhere here. That represents a 70th percentile, which means 70% of other students did worse than 16 out of 20, and then the other 30% did better. So 16 out of 20 is just a cutoff point. So percentiles are cutoff points, so that k% of values are below and the rest are above that cutoff point. So we're going to focus today on quartiles. Q1 always represents the 25th percentile. So whatever your cutoff value is for Q1, 25% of values are going to be below Q1. So Q1 always represents the 25th percentile. It's also called the first quartile. It divides the bottom 25% of data from the top 75%. Now Q2, this is the 50th percentile. This is also called the median or the middle value. And Q2, it separates the bottom 25 and 25, so the bottom 50% from the top 50%. Second quartile separates the bottom 50% from the top 50%. And then Q3, that is the 75th percentile. So Q3, it separates the bottom 75% of data. We got 25, 25, 25 from the top 25%. So Q3 separates the bottom 75% of the data from the top 25%. So every time we see Q1, Q2, Q3, these are the three things we're going to keep in mind: 25, 50, and 75, just kind of like quarters. So our objective today is going to learn how to find Q1, Q2, Q3, and interpret box plots. So a box plot is a summary of these 5 values. It's a graphical representation of these 5 values. Our 5 values are minimum, Q1, median, which is Q2, Q3, and the maximum. And on a box plot, the first dash always represents the minimum. Okay, the second dash always represents Q1. The third dash always represents Q2. Fourth dash always represents Q3. And the fifth dash always represents a maximum. Now, you guys are not going to have to make your own box plot because technology does that for us. You just have to know how to read a box plot. And how do you read it? Minimum, Q1, Q2, Q3, max. So 25% of values are below Q1, 50% are below Q2, and 75% are below Q3. But our job today is going to learn how to find Q1, Q2, and Q3. So here's a set of data values. We got 2, 4, 5, 5, 6, 8, 9, 10, 11, 13, 14. What I'm going to do is I'm going to actually write those out. So we got 2, 4, 5, 5, 6, and then I have 8, 9, 11, 13, 14. So the first thing I want to do is I want to find the 5-number summary, which means I want to find the minimum, the Q1, the Q2, the Q3, and the maximum. So the minimum is easy. The smallest value is 2. The maximum is easy. The largest value is 14. So that's done. Now, how do you find the middle value? So it depends. If you have an even number of values, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to start with Q2. If you have an even number of values, then your median is the average of the 2 middle values. Okay, so once again, if we have an even number of values, then the median is the average of the 2 middle values. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 values, so our median, if you look at the 2 middle values, they're going to be 6 and 8. So it'll be the average of 6 and 8. So in order to find Q2, in this case, I'm going to add 6 plus 8 divided by 2. When you take an average of 2 numbers, you add those and divide by 2. That's 14 divided by 2, or 7. So my Q2 is going to be 7. Okay. If there were odd number of values, then the median is just the middle value. Okay, if there are odd number of values, the median is simply the middle value. But in this case, we have an even number of values. All right, let's take, how do you find Q1? Well, to find Q1, we're going to take our data set and we're going to separate that into the bottom half and the top half. So this is your bottom half and this is your top half. So Q1 is going to be the median of the bottom half. Okay, Q1 is a median of the bottom half. So the bottom half is this 1, 2, 4, 5, 5, 6. And in this case, we have 1, 2, 3, 4, 5. We have an odd number of values. So our median of that is going to be 5. And Q1 is a median of the bottom half. So our Q1 is going to be 5. And then similarly, Q3 is going to be the median of the top half. It's a median of the top half. So if you look at the top half, our middle value is 11 because we have an odd number of values. So our Q3 is going to be 11. Let's take a look at the next data set. We have, and I'll write this out, we got 10, 13, 14, 18, 22, 23, and then you have another 23, another 23, and then you have a 25, a 30, and a 32, and a 51. So we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We got 12 values here. So let's start with the minimum. So our minimum value is going to be 10. And our maximum value is going to be 51. Okay, now we have Q1, Q2, Q3. I'm going to start with Q2. Because I have 12 values, my Q2 is going to be the average of the two middle values. So my two middle values, so you got 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So my two middle values are going to be these two, because now we have 5 below and 5 above. So if I take 23 plus 23 and divide by 2, to take the average, I add those, divide by 2, that's 46 divided by 2, which is going to be 23, and that's going to be our Q2. For Q1, I split up my data set into the bottom half and the top half. And then I'm going to look for what is the median of the bottom half. So my bottom half has 1, 2, 3, 4, 5, 6 values. So when my bottom half has 6 values, an even number of values, I take the two middle values and I find their average. So for Q1, I'm going to be taking 14 plus 18, divide that by 2. 14 plus 18 is 32. 32 divided by 2 is 16. So my Q1 is going to be 16. Q3 is going to be the median of the top half. So my top half has 1, 2, 3, 4, 5, 6 values. The two middle values are 25 and 30. So for Q3, if I take 25 plus 30 and I divide that by 2, it's going to be 55 over 2, which is going to be 27.5. Okay, so hopefully that clarifies how to find Q1, Q2, and Q3. Oh, you know what? Let's ignore the other one. So a box plot. So if you look at our first data set, our 5-number summary was 2, 5, 7, 11, 14. That's from here, 2, 5, 7, 11, 14. For our first data set, this is our minimum, which is 2. And then we said our Q1 is 5. And then our Q2 is 7. And then our Q3 is 11. And our maximum is 14. It goes in that order: minimum, Q1, Q2, Q3, and max. So we got 2, 5, 7, 11, and 14. And remember, Q1 means 25% of all data is below Q1. Q2 means 25 and 25, 50% of data is below Q2. And then Q3 means 75% of data is below Q3. So we're going to skip this one because we did a box plot example here, and we're going to skip this one. But here's a quick little diagram for that. And this is, I'm not going to go over it too much, but this is your minimum, this is your Q1, Q2, Q3, and max for the second data set. All right, so now we're going to talk about outliers. So an outlier, it's not just the highest or lowest value. An outlier is a value that is significantly higher or significantly lower than everybody else. Okay, so I'll give you an example. Let's say that you have 5 players on a basketball team, and the 5 players score 10, 11, 12, 14, and 15 points. The person who scored 15 points, that person scored more than everybody else. But that person wouldn't be an outlier, because to be an outlier, you have to do significantly higher or significantly lower than the average. Here's another example. You have another team with 5 players. Players score 10, 11, 12, 14, and then the next player scores 56 points. The fifth third scores 56. This person would be an outlier because they did significantly better than the rest of the team. So they would be an outlier. So an outlier is a value that is significantly higher or significantly lower than everybody else. And outliers are important because let's say that you own a company and that company is sales based, and you want to figure out, hey, do we have any outliers? So outliers aren't just people that did the best, but that did significantly better than everybody else that we could promote. Or do we have any outliers on the lower end? People who are like really underperforming everybody else by far. Again, it doesn't mean they're the lowest. It means they're way worse than everybody else. That's what we're going to determine. How do you take a data set and find the outliers? So to find outliers, we have these fences. We got the upper fence and we have the lower fence. Now the rule is that, let's say this is your data set, and for a data set we calculate a lower fence and we calculate an upper fence. So any values that are in between the fences, these are normal values. So think of them as boundaries. But anything that's below the lower fence or above the upper fence, so if it's below the lower fence or above the upper fence, these are your outliers. So our outliers are always going to be below the lower fence or above the upper fence. Okay, so for example, our upper fence formula, so to find out what that upper fence is, the upper fence formula is going to be Q3 plus 1.5 times the IQR. And our lower fence formula is Q1 minus 1.5 times the IQR. And what is the IQR? The IQR is just the difference between Q3 minus Q1. So to figure out our upper and lower fences, we need two things. We need Q3 and Q1 because those two are part of our formulas. So this is the same data set we did earlier. Our 5-number summary was as follows. Our minimum was 10. This is our minimum. Our Q1 was 16. That's Q1. Our Q2 was 23. Our Q3 was 27.5, and then our maximum was 51. But to find upper and lower fences, all we really need is we need the Q3 and the Q1. Okay, so our Q3 is equal to 27.5 and our Q1 is 16. So these are the two relevant numbers that we need to identify outliers. Okay, so first thing we need is IQR. IQR is Q3 minus Q1. That's 27.5 minus 16, which is 11.5. To find the lower fence, we're going to take the formula Q1 minus 1.5 IQR and we just plug it in. So Q1 is 16 minus 1.5 times IQR, which is 11.5. If you put this into a calculator, we get negative 1.25. That's our lower fence. So any values that are below negative 1.25 are going to be outliers. If you apply Q3, which is 27.5 plus 1.5 times IQR, we get 44.75. Now, any values that are above 44.75, those are also going to be outliers. If I were to graph this, this is my data set. Okay, my lower fence is going to be negative 1.25, and my upper fence is going to be 44.75. Now, I look at the numbers I'm given here, and I ask myself, do I have any values that are below negative 1.25? Because remember, anything in between, these are normal values. Anything in between negative 1.25 and 44.75, these are normal values. So I ask myself, do I have any values below negative 1.25? And I don't. Do I have any values above 44.75? I do, 51. 51 is above 44.75. So my outlier is going to be 51. So what I'm looking for is, so if I were to plot all these, and I'm not going to plot all of them, but like this is 10, this is 13, this is 14, et cetera, then we get to 32, which is here. So 32 is still between negative 1.25 and 44.75, so it's a normal value. But anything that's to the right of 44.75 is an outlier. To the left of negative 1.25 is an outlier. And we don't have any values to the left of negative 1.25, so we have no outliers on the left side. But to the right of 44.75, we have 51, which means it is an outlier. Okay, so to find outliers, identify your Q1, Q3. How do you find Q1, Q3? We did that back here. We learned how to find Q1 and Q3. Once you find Q1, Q3, apply those to the formulas, and you will have your lower and upper fences, and then anything below the lower fence or above the upper fence is an outlier. All right, so these are the two 2021-2022 salaries of the Los Angeles Lakers. And here, our objective is to find the 5-number summary, and then also to identify any outliers. So let's start with the lowest value. The minimum is going to be 0.46, and the maximum is going to be 44.21. We now have to find the Q1, the Q2, and the Q3. Okay, so let's take a look at how many values we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We have 18 values. So because we have an even number of values, okay, we got 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to take these 8. And then I have 1, 2, 3, 4, 5, 6, 7, 8. I'm going to take these 8. So we have 8 over here. I'll label these 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That leaves 2.64 and 2.64 as my two middle values. So my Q2 is going to be 2.64 plus 2.64 divided by 2, which just gives us a 2.64. That's my Q2. Okay, my Q1 is the middle of these 8 values. So now, I'm sorry. I'm going to, before I do that, I have to split the data set exactly in half now. And because I have 18 values, I'm going to take 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4, 5, 6, 7, 8, 9. So I split my data set in half. And for my Q1, I take the median of the lower set. And for my Q3, I take the median of the upper set. So my lower set, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 values. So my exact middle is going to be 1.79. Now my upper set also has 9 values, so my exact middle is going to be 5. Because I have 4 below, 4 above. Same here, 4 below, 4 above. So my Q1 is 1.79, and my Q3 is 5.00. And if you're wondering who the 44.21 million was, this is Russell Westbrook, who had, of course, a notoriously horrible season with the Lakers. Still made a 44 million though. All right. So now that we have this, we need to identify any outliers. But to find outliers, we need to find the lower fence and the upper fence. Okay. So what do we need for these? We need Q1 and Q3. So Q1 is 1.79 and Q3 is 5.00. All right, so first thing I want to do is I want to find my lower fence, which is going to be Q1 minus 1.5 times the IQR. For that, I need to know my IQR. So my IQR is going to be 5 minus 1.79. If I subtract that, I get 3.21. That's my IQR. So my lower fence is going to be Q1, which is 1.79, minus 1.5 times the IQR, which is 3.21. If I put this into a calculator, if I take 1.79 minus 1.5 times 3.21, I end up with negative 3.025. So this is my lower fence. For my upper fence, my formula is Q3 plus 1.5 times the IQR. So my Q3 is 5 million, plus 1.5 times the IQR, which is 3.21. So if I take 5 plus 1.5 times 3.21, then I'm going to end up with 9.815 as my upper fence. Now remember, outliers are any values that are below the lower fence or above the upper fence. It's my upper fence. So nobody made less than negative 3.025 million. It's not possible to earn negative. Well, I guess you can be in debt, but in this case, no one earned less than negative 3.025 million. Then we ask ourselves, do we have any outliers on the upper side? So did anybody make more than 9.815 million? And they did. These three players, who are Anthony Davis, LeBron James, and Russell Westbrook, they made more than 9.815 million. So we do have outliers, and our outliers are going to be the people who made 35.36 million. That's Anthony Davis, 41.18 million LeBron James, and 44.21 million Russell Westbrook. These are our outliers. Okay, so hopefully that helped clarify our Q1, Q3, and also our outliers. All right, last one is we're going to learn to read box plots here. So this one says what percent of data is below the number 12. You always want to label each of these as minimum, Q1, Q2, Q3 max. And then we ask ourselves, what does 12 represent? Now, after we label these, which is important, we know that Q1 represents the first quartile, which means 25% of values are going to be below Q1. So what percent of values are below the number 12? That would be 25%. And we're going to skip part B. So remember, Q1 is always 25, Q2 is 50, Q3 is 75. Okay, skip part B, it's kind of a badly written question. The next one here, we have two box plots, one for construction workers and one for teachers. First thing we want to do is we want to label these as minimum Q1, Q2, Q3 max, and then minimum Q1, Q2, Q3 max. So the question is, if you make 30,000, you make more than what percent of teachers? So we're looking at 30,000, which is here, and then we're going to extrapolate that up to teachers. So 30,000 represents Q1 for teachers. And we know that Q1, it means 25% of data is below that. So somebody who makes 30,000 make more than 25% of all teachers. Now part B says if you make 30,000, you make more than what percent of construction workers? Well, if you make 30,000, you make the minimum salary for a construction worker. And while other people might make as much as you, nobody makes less than you. That means you make more than 0% of construction workers. So 30,000 is the minimum for construction workers, which means nobody makes less than you. You don't make more than anybody. Okay, now we're going to be doing a comparative analysis. We're going to compare these two box plots. If you make more than 50% of construction workers, so let's break this down. 50% always refers to Q2. So we're looking at Q2 for construction workers, which is 40,000. So if you make more than 50% of construction workers, you make more than what percent of teachers? So now let's think about this. Q2 for construction workers is 40,000, which is the same thing as Q3 for teachers. And Q3 is 75%, so 75%. Now, part D says, how much do you need to make in order to make more than 50% of all the teachers? So 50%, this is always going to be Q2. And we're looking at teachers. So let's look at Q2 for teachers, which is here, and that's 35,000. And then we're going to skip letter E. So just look at these in terms of Q1, Q2, Q3, 25, 50, 75. Okay. Last example here. John's an actuary. So actuaries, this is John. And makes more than 50% of his peers. So 50% means Q2. So first thing, let's label these as minimum Q1, Q2, Q3 max. And John's an actuary, makes more than 50% of his peers. So for actuaries, 50% would be Q2, which is going to be 75,000. Now Jemima is a CPA and makes more than 75% of her peers. So 75%, this is going to be Q3. And then CPAs are here, so this is going to be Jemima's box plot. So Q3 is going to be right there. 75K. So who makes more? They both make about the same. Then lastly, someone who makes more than 25% of actuaries will make more than 1% of CPAs. So we're looking at actuaries. So we're looking at the second box plot. And 25%, it means Q1. So let's look at Q1 for actuaries. That's right there. The question is, they will make more than what percent of CPAs? So if you go up to CPAs, that same value, which is about 65,000, that's Q2 for CPAs, and Q2 means 50%. Okay, and that's it. That's it for this lesson. We're going to skip that last one.